Drawing images is a little bit trickier than drawing lines, so it's worth looking at image drawing in a little bit of detail. So the first point is that you don't want to load the image across the internet every time. So loading the image shouldn't be placed in the paint method. It should be placed in the init method. But if you're going to load the image in the init method, how do you pass the data to the paint method? And the answer is you store it in an instance variable. So I make an instance variable to store the image, and then I load it in init. The most common way is to load it from a relative URL. Go to the address of the applet itself, and then go to this relative address to get the image. But it's also possible in principle to load from an absolute URL, and we'll talk about that in a few slides. Okay, either way, you load the image in init, you store it in the instance variable, and then in the paint method, you say draw the image with this top left corner on this window. And usually the word this is used for the window. It means draw it in me, but it's possible also to have sub-windows, and so the applet could specify which sub-window it gets drawn in. So normally you draw the image, and then you give the X and Y location where you want the top left corner of the image to be, and then you supply this as the last argument. Okay, it sounds pretty simple. Let's look at some code, which also looks pretty simple. So I made a folder called images in my project. I put a GIF image in there. And then this says go to the location that the applet's in. Go to this relative location. Load the image and store it in this instance variable. I do that in init, so it only gets done once. And then my paint method says draw the image with the top left corner at 0, 0. Remember, 0, 0 is the top left corner of the browser, not the bottom left corner, on the current window, the main applet. Okay, that all seems very straightforward. And if I run it locally, it also seems very straightforward. But here's the surprising thing. What happens if I deploy this to a web server and I access it from a browser over a slow internet connection? What do you suppose the image takes 10 seconds to load? Looking at this code, what's going to happen for seconds 1 to 9? And if you look at this code, you say, well, it loads the image. And then when the init method finishes, eventually it'll call paint and it'll draw the image. So if it takes 10 seconds to load the image, for the first 9 seconds I don't see anything. And then on second 10, the image pops up. But if you go and run that application on a slow internet connection, that's not the behavior you see. After 1 or 2 seconds, you see the top of the image. And then after a few more seconds, you see this much of the image, and then this much of the image, and then this much of the image, and then this much of the image. That seems inconsistent with how this code is written. And the answer has to do with the behavior of getImage. GetImage starts loading the image in a background thread, in a background process, and it returns immediately. This idea of background processes that either start automatically or that we start is a very common theme in Java. Java makes great extensive use of background images, and we'll do that quite a lot ourselves later. But let me just kind of briefly summarize the benefit of doing that. And so what happens is it's loading in a background process, paint gets called, and this image is not complete yet. So paint draws whichever part of the image is already there, which is, the top part. And then paint says, the image is not done. I should redraw again a little later. And so a little while later, it draws more of the image, and it keeps doing that until the whole image is there. Well, this is very useful because the end user sees progress. So one of the benefits of background threads is less latency. The user sees some feedback right away. A second benefit is overall download speed. Suppose that you're loading 2 different images from 2 different servers. And suppose that the rate limiting step was how fast the server sends it to you, not how fast your system can accept incoming network connections. So the bandwidth of your incoming system is not maxed out, but the servers aren't sending you the images fast enough. By loading 2 images this way, when you're waiting for the server to send you the first image, you can be downloading the second image and vice versa. And so it's get a little bit at a time, they kind of dribble in, and you're doing them concurrently. You're switching back and forth between getting the 2 images. Java does this automatically for you, but you can also do it yourself. And so this idea of background processes so that people see feedback right away, and so that if you're waiting for something, you get less total time because you can do something else while you're waiting, is a common theme that we'll revisit lots of other times throughout the course of this live lesson series. So we saw that in an applet, you normally load an image from a relative address. You call get code base, that's where the applet's stored, and then you go to a place relative to that to get the image. It's possible in principle to load from an absolute URL. That's not very useful for applets because of the applet security restrictions, but that's very useful for desktop applications. And so it's possible to load from an absolute location, and there's a class called URL. The plus here is just string concatenation. I just broke it across 2 lines to make it fit. And if you try to load in the init method from a URL, then the way we've done it normally, your code won't even compile. And Eclipse puts a little red X on the left-hand side, and it says, you need to either catch or throw malformed URL exception. What in the heck is going on? Well, if you look at the online API for the URL constructor, it says that it throws a malformed URL exception. If it says that it throws a malformed URL exception, that means it can potentially have an error. It might have an error. And in Java, everything is typed, so errors are typed. So errors or exceptions have types. And the type of the possible error is malformed URL exception. What that really is saying is if you type in a URL that's illegal, if you type in HTTP instead of HTTP, or you type in Gopher, the Gopher protocol is not supported by Java, no one even knows what that is anymore, then the call to the URL constructor will have an error. And so you need a try-catch block. A try-catch block is something that you use throughout all of Java. Run some code, and if something goes wrong, jump down to the catch block. Try-catch blocks are so important that it's worth discussing them separately. Let's do that in the next section.